Well, good day everybody. This is Chris with the Ancient Scholar. I hope this video finds you doing well. So in this particular video, what I'm going to do is I'm going to take you through the basic, and I mean basic setup of a Hamilton T-1 ventilator. This is not going to be an extensive and exhaustive description of all of the things that you can do with this ventilator, but rather a basic overview. But we can draw upon the prior videos to begin to understand a little bit about what it means to select a mode of ventilation on the Hamilton T-1 ventilator. And in subsequent videos, I think I may talk about some of the specific options that you're able to employ, because this particular ventilator can actually do quite a bit, but it is a little confusing. Like I've said in prior videos, a lot of companies kind of have their own take on ventilators. They kind of have their own terminology, and they have a lot of proprietary names and definitions for things that kind of fall outside of the standard conventions that are often used and taught when people learn about mechanical ventilation. And that's going to vary from ventilator to ventilator and from company, from manufacturer to manufacturer. So what you have to do is you have to have a good grasp on the fundamentals and then understand how that maps onto the specific terminology that is used by each manufacturer. So with that in mind, I have the Hamilton T-1 ventilator set up. I've got my tubing. This is the coaxial tubing attached. I also just have some accessories. I've got the heat and moisture exchanger attached. I've got my inline suction catheter attached, and I have my inline CO2 sensor for waveform capnography. And then Hamilton, when we got our ventilator, they sent us this modified endotracheal tube. That's really nice. So this modified endotracheal tube would simulate a patient, so connecting to the endotracheal tube of a patient. All right, so that's where this would go. And then the distal end of the endotracheal tube has a 15mm adapter that connects directly into the test lung here, so that allows us to simulate a patient and work through the ventilator setup. All right, so we have our tubing set up, we have our test lung attached, and the basic accessories that we're going to use are HME/HEPA filter, inline suction or Ballard tubing, as well as our capnography, which I feel these are all critical or crucial accessories. At an absolute minimum, you need to have capnography, but you really should have a HEPA filter and an inline suction unit. All right, but that aside, let's focus on what this video is about. So what you're going to do is you're going to hold the power on button down. Should take about 2 to 3 seconds. You'll see the green light. The ventilator is going to run through a self-test. I've already completed videos on doing a leak test and testing the flow sensor, the expiratory and inspiratory flow sensor, so we're not going to do that here. But you can see the ventilator is running through its own internal test, and that usually takes less than a minute. So this is why a lot of people will often keep the ventilator just like this in its standby mode. So when you turn the ventilator on, it will default into this standby mode. And a lot of hospitals, this is how they'll store the ventilator, plugged in standby mode. That way, if they need to initiate mechanical ventilation, they don't necessarily need to go through that additional step of waiting for the ventilator to run through the self-test. That's just going to be whatever your institutional policies and protocols may be. So this is the main standby screen. You're going to see a couple of things. There are some presets here. So think of these as just like super generic basic settings that you can put into the ventilator. So if you have like a generic adult male and you just need some generic bread and butter settings to get by, and then you can put in more sophisticated settings at a later time, you can do that. And so you could have like maybe some generic adult settings, some generic pediatric settings, or a generic adult male, generic adult female, and then just generic pediatric. There is a neonatal mode, but if you have a smaller patient, less than I believe it's about 3 kilograms, this tubing, the standard coaxial tubing, will not work, and you actually need specialized tubing, which is smaller, has less dead space, and so on. And it has its own specialized neonatal flow sensor. You need specialized tubing, and so if you attempt to select neonatal, it'll say wrong expiratory valve, so you cannot do that. So we'll just go with adult. There's also what's called the last patient option, and then this just defaults to the last patient that you had set up. And as you can see here, we don't really have much of anything because I haven't had a patient on this yet. So what we're going to do is we're just going to do a basic setup. We can talk about presets later on, but we're just going to do a basic setup with an adult patient. And what you want to do is you want to select the biological sex, either male or female. And then you need to know your patient's height, because the height and the biological sex is used to determine the ideal body weight, right? And those of you in respiratory school should have learned the formulae for estimating ideal body weight. And again, this is not ideal body weight for BMI purposes. This is ideal body weight based on patient lung size, right? So this is an important thing to get as close as you can. So let's just stick with a male, and let's just say this is a 172 centimeter male. So you can see I can select things with the touch screen. All right, and so 170, 172, and then you use the dial over here to go up and down, and then you push it to finalize the option. So I have a 172 centimeter male, and the ideal body weight is 68 kilograms for that particular patient. All right. Let's go back into standby. All apologies. All right. So we've got our male and 172 centimeters. All right. So the next thing that I'm going to do is I am going to go to modes. And you see I've got a laundry list of modes. This is where things can get very complicated. So you can see here, this says volume controlled adaptive. And so what you might think is that, oh, this is the volume control, and then this says pressure control biphasic here. Oh, so this is when talking about modes. These are my control variables, volume and pressure. Oh, this is volume control, this is pressure control. No, 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 not exactly. Technically, these up here are pressure controlled, but they control pressure while also targeting volume. So volume is a primary targeting variable. So these modes here are also pressure control at the end of the day. And it's funny because I had to actually look it up as I was going through. Yes, I actually went through the manual, which I would recommend you go through for the Hamilton T-1. And when you go to your modes here, there you go, volume targeted modes, adaptive pressure control. So volume is a targeting variable, but those modes are still pressure controlled. All right, so you've got this SCMV plus, SIMV plus, and VC stands for volume support. All right, so the CMV here is control mechanical ventilation, but it is actually, the type of CMV is assist control. So this would be assist control. Technically it's pressure control, but volume is a targeting variable, okay? SIMV is synchronized intermittent mandatory or mechanical ventilation. SIMV plus, it is technically pressure controlled, but volume targeted. And then you've got what's called volume support. And then you've got your more conventional, should we say, a little more conventional pressure control ventilation, PCV, that's pressure control ventilation plus, spontaneous, duopap. Duopap is essentially essentially Hamilton's trademark name for BiPAP. I mean, BiPAP is technically trademark where you have a spontaneously breathing patient, and when they inhale, they get a pressure, and when they exhale, they get a slightly lower pressure, right? You've got something called APRV, airway pressure release ventilation. And look down here, you've got intelligent ventilation, and look at that, ASV, adaptive support ventilation. And I bring that up because that is something I mentioned in a prior video when talking about the schemes, and I talked about the optimal scheme where the ventilator is able to adjust targets of the ventilatory pattern to optimize some area of performance or some performance characteristics such as work of breathing. Example, ASV, there it is, right? So you can see that the Hamilton T-1 ventilator has different schemes, all right? So what we're gonna do is we're just gonna select the CMV plus, which just think of this as assist control. This is assist control, technically pressure control, but it is volume targeted, even though it says volume controlled. All right, just to make it more complicated. All right, there is also a CPR option. So if your patient goes into cardiac arrest and you're doing chest compressions, you can select the CPR option as well. But let's just stick with a bread and butter CMV plus, assist control. Go down here, hit confirm, and then you are going to get your targeting variables based on that mode that you selected, right? So you can see you've got your pressure limit because technically this is pressure control ventilation, right? So this is the high pressure, right? So once the ventilator senses, right, if your pressure limit is at 30 centimeters of water, once 30 centimeters of water is hit, that will cycle, that will cause the ventilator to cycle into exhalation, and that's what makes it pressure controlled. Now, you do have volume, you do have tidal volume as a limiting variable, all right? So let's just select 500 milliliters. All right, there we go. So it is going to target a 500 milliliter tidal volume, but it will not go beyond a 30 centimeters of pressure, right? It is still pressure controlled, but it is targeting a 500 milliliter tidal volume. I'm gonna set the respiratory rate. Let's just say we're gonna set that at 10, select. So this is a mandatory rate. So what I'm saying is at a minimum, the patient needs to receive 10 breaths a minute, a tidal volume of 500 milliliters per breath. But again, we are targeting a pressure limit control, right, variable of 30 centimeters of water. And with those settings, that's going to give me an IDE ratio of inspiratory of 1 to expiratory of 4, IDE of 1 to 4. I've got my PEEP, 5 centimeters. The flow trigger, so this is to trigger the ventilator, okay, because technically this is assist control, even though it's CMV, it's really assist control. a type of CMV. And when the ventilator senses that the patient is sucking in a flow of 5 liters per minute, that will trigger the ventilator. That will tell the ventilator, oh, the patient's trying to take their own breath. I will give them this breath that we have set here, right? That's what assist control is. Let's go back in there, okay? So, go back here. Go back here. All right. Oxygen, that's your FiO2. I'm just going to set that to 21% since I don't have oxygen going into the ventilator here. You can make the trigger more or less sensitive. So if I make the trigger more sensitive, I'll decrease it. And that means that the patient has to generate less flow to trigger the ventilator. And I can make the ventilator less sensitive by increasing, and that means the patient has to generate more flow before it triggers the ventilator. So lower is more sensitive and higher is less sensitive. We'll just keep it at 5 liters per minute right now. That's my inspiratory time, 1.2 seconds. My expiratory time, 4.8 seconds, and that gives me an IDE ratio of 1 to 4.0. And based on this tidal volume, it is going to give my patient a 7.3 milliliter per kilogram tidal volume, which is within that 6 to 8 milliliters per kilogram of recommendation for tidal volume if you're looking at lung protective strategies. So these are the basic settings. There are some additional settings. There's a P ramp and then there's psi. I can talk about ramping in another video. Psi, if you select that what that essentially does is that gives a patient a bigger breath, kind of like sighing, when you sigh and you and it'll do that several times an hour. And some people think that helps with recruiting alveoli. We'll keep that off for now. All right, so here we are with our basic. If we're happy with our settings, you want to hit confirm. All right, and at this point, if you're ready to start ventilation, you can go ahead and do that. You also have controls here if you want to go back into your controls, and then you've got your alarm settings. What I would recommend is get your basic settings in, get your basic mode in, all right, and then go ahead and start ventilation. And once it starts ventilation, there are several options for monitoring we'll talk about in other videos. So here you've got your pressure time waveform, you've got your flow time waveform, and then you've got your volume time waveform. You also have loops, and it's going to give you some basic information. You've got a peak pressure. That's the peak inspiratory pressure, the highest pressure encountered. You can see it's nice and low here at 14. This is the exhaled minute ventilation, in this case about 1.78. This is the tidal volume that's being delivered, 216 milliliters, and then this is the rate. So you can see at this point in time, the lung is not triggering the ventilator, right? And so that patient is just getting the bare mandatory settings. So what you want to do is you kind of want to get the patient on the ventilator. It's going to alarm, and remember the most important button there is shut it up for a couple minutes. I've got a low minute volume alarm. So what you want to do is you get the patient on the ventilator, kind of figure out where they're at baseline, and if you're happy with what you see, and if things are looking good, then you go in and you set your alarms. So with your alarms, generally what I like to do is I like to go on my high pressure alarm. I go 10 above and 10 below my average peak inspiratory pressure. So I'm going to set this at about 43. And then I'm going to go down to about 20 to 23 on my low pressure alarm. Your expiratory, your minute ventilation alarm, my low, I'm going to go a little lower here, 3 liters per minute, and then 10 liters per minute for the high. This is the respiratory rate. The low doesn't really matter because this is a mandatory settings, right? I have a mandatory 500 milliliter tidal volume targeted, 10 breaths per minute. So I don't need to, I really only need to worry about this if I have a patient in a spontaneous mode. But you do want to set a high respiratory rate, 40 is fine. And then, your tidal volume. So 280 is good for now, and then 850, I'm probably gonna go a little lower on that. Let's go 650. And then apnea time, this really only applies in a spontaneous mode. And essentially what this is this detects if the patient quits breathing for a certain period of time, then the ventilator will alarm and it will switch itself into a mandatory mode so the patient actually receives mandatory settings. 20 seconds is kind of like a generic standard apnea time. That doesn't matter in CMV/AC because this is a mandatory mode where the patient receives mandatory settings. And at that point, you're good to go, and we are ventilating our patient, and you're just going to monitor and you're going to make changes as necessary. And in subsequent videos, I'm going to talk about some of the other modes that you can do, kind of how they work, and talk a little bit about some things you can do to address certain types of patient pathologies, obstructive pathologies, restrictive pathologies, things of that nature. But at least this gives you a basic understanding of how to run through the setup of the Hamilton T-1 ventilator, and I hope you all found this video helpful. Thanks again, and we'll see you in the next one.